Hello everyone, and welcome to PadhaiX. In this video, we'll solve NCERT Class 11 Physics question number 3.13 from the chapter Motion in a Plane. Let's first read the question carefully. A cricketer can throw a ball to a maximum horizontal distance of 100 meters. Using this information, we have to determine how high above the ground the same cricketer can throw the ball. At first glance, it may seem that we don't have enough information to find the height. But don't worry. Using the concepts of projectile motion, we'll first determine the speed of the throw and then calculate the maximum possible height. Let's get started.
Now, before we jump into the calculations, let's quickly plan our approach. First, we'll find the maximum speed with which the cricketer can throw the ball. Next, we'll determine the angle at which the ball should be thrown so that it reaches the maximum possible height. And finally, using these two pieces of information, we'll calculate the maximum height the ball can reach. So, here is a cricketer. Let's call him Raj Kumar. Now, Raj Kumar is going to throw the ball using his maximum possible strength. Since he is using his maximum strength, he's also throwing the ball with the maximum possible speed that he can generate. In other words, he simply cannot throw the ball faster than this speed. I hope this idea is clear. Maximum strength means maximum initial speed. Keep this point in mind because we'll use it throughout the solution. Now, let's see what happens when Raj Kumar throws the ball at different angles. First, he throws the ball at exactly 45 degrees. The ball follows this path and lands here. Next, he reduces the angle to less than 45 degrees. This time, the ball lands before reaching the previous distance. Now, he throws the ball at an angle greater than 45 degrees. Again, the ball lands before reaching the previous distance. So, what did we observe? Among all these three cases, the ball travels the maximum horizontal distance when it is thrown at an angle of 45 degrees. This is one of the most important results of projectile motion. When the initial speed remains constant, the horizontal range is maximum at 45 degrees. Please remember this concept. Now let's come back to our actual question. The question tells us that the cricketer can throw the ball to a maximum horizontal distance of 100 meters. What does that immediately tell us? It tells us two things. First, the cricketer is throwing the ball with maximum strength, which means maximum initial speed. Second, since the distance mentioned is the maximum horizontal distance, the angle of projection must be 45 degrees. So now we know the horizontal range is 100 meters and the angle of projection is 45 degrees. How did we conclude that? From the concept we just understood. Now, using these two pieces of information, let's calculate the maximum speed with which the cricketer throws the ball. Here are some important projectile motion formulas that you should always remember. Time of flight, maximum height, horizontal range. Now, ask yourself, which formula should we use here? Since the question gives us the maximum horizontal distance and we have figured out angle of projection, the horizontal range formula is the correct choice. R equals u squared sine 2 theta divided by g. Now we'll simply substitute the given values. The horizontal range is 100 meters. The angle of projection is 45 degrees. And we'll take the value of g as 10 meters per second squared. The equation becomes 100 equals u squared sine 90 degree divided by 10, and sine 90 degrees equals 1, which gives 100 equals u squared divided by 10. Multiplying both sides by 10, we get u squared equals 1,000. We don't need to calculate u separately. This value of u squared is enough for the next part of the solution. Now comes the most important part of the question. The question asks, how high can the cricketer throw the ball? Think for a moment. If someone wants to throw the ball to the greatest possible height, should they throw it at 45 degrees? No! To achieve the maximum height, the ball should be thrown vertically upward. That means the angle of projection becomes 90 degrees. The initial speed remains the same because the cricketer is still using his maximum strength. Now, let's find maximum height. We will use this formula for maximum height. H equals u squared times sine square theta divided by 2g's. Since the ball is thrown vertically upward, the angle theta is 90 degrees. And we know that sine 90 degrees is equal to 1. So the equation becomes h equals 1,000 times 1 divided by 2 into 10, which gives h equals 50 meters. So the maximum height to which the cricketer can throw the ball is 50 meters. And that's our final answer. The cricketer can throw the ball to a maximum height of 50 meters above the ground. I really like this question because it tests concepts, not just formulas. If you understand when to use 45 degrees and when to use 90 degrees, questions like this become very easy. If you found this explanation helpful, please hit the like button, share this video with your friends, and don't forget to subscribe to PadhaiX for complete NCERT physics solutions. Thanks for watching, and I'll see you in the next video with question 3.14.